This picture should not exist. Yes, because for years the AIM-260, America's next big air-to-air missile, has lived in a fog of secrecy, rumor and wishful thinking. But this single image, this one, taken in May 2026 by photographer Jonathan Tweedy, cuts through all of that. And it tells a very different story from the one the internet has been repeating. So welcome, I am Gas, and this is Millennium 7. For most of its life, the AIM-120D was the king of beyond visual range combat. It outranged and outmaneuvered anything its rivals could field. It was the missile everyone else was trying to catch. But then Russia changed the equation. The R-37M arrived with a range that simply outclassed the AIM-120D, and the R-77M, Russia's newest medium-range missile, essentially matched the AIM-20Ds. So suddenly, US didn't have the range advantage anymore. And then China leapfrogged everyone. The PL-15 pushed the engagement envelope far beyond the AIM-120D. And the PL-17 extended that reach even further into the realm of ultra-long-range kills. Suddenly, high-value assets like AWACS, tankers, and other support aircraft were on the line of fire. And by the way, recently, some Pakistani's PL-15E ended up in Indian hands. And if India gets a look, it is well possible that the United States get a look as well. So it is in the realm of possibility that by now the United States have a relatively good idea of what the PL-15E could actually do. So, in 2017, explicitly mentioning the appearance of the PL-15 as the trigger, US launched a crash program, the AIM-260 Joint Advanced Tactical Missile. The goal was simple: outrange the PL-15, field it by 2022, a fast, focused response to a fast-moving threat. So, this is the range of the AIM-120, well, at least according to the numbers that are in the public domain. This is the expected range for the AIM-260. It doubles the range. Tests were reported in 2020, more tests were reported in 2023. Guam and Eglin air bases received special installations for the missile testing. But no photos, no leaks, nothing you could point to and say, yeah, there it is. Some renders appeared in officially released documentation, but that was it. And then in 2024, the rumors started. Integration problems. Issues with the F-22 weapon base, issues with the F-35 weapon base. The missile wasn't apparently fitting the way it was supposed to. And in the same years, there were rumors of a pre-production order and a bigger order in 2025. And both had consequences. But then later that year, the internet filled the silence with its own stories. Claims that the AIM-260 was already in production, already deployed, already outperforming everything else in the sky, but none of it had any evidence. And then, in May 2026, this photo appears. An F-18 carrying what looks unmistakably like an AIM-260. Not in a classified hangar, not in a secret test range, just flying over the Gulf of Mexico. And suddenly the narrative collapses. The missile isn't operational, isn't secretly deployed. I mean, the US Air Force and the Navy are officially planning to spend $15.6 billion more on development and production. These are official numbers, so this program is still very much in progress. missile is long and thin, definitely an air-to-air weapon. And the AIM-260 is the only missile in development that fits this profile. A few months earlier, a test aircraft at Eglin carried a nose installation shaped exactly like this missile. On this photo, we see the next step. The markings are typical of a test article, reference points for cameras and sensors, but what about these small squares near the radome? Well, they could be simply panels of different color, or could they be integral antennas? After all, the missile is supposed to feature an advanced AISA seeker, which will likely be under the radome, and a two-way data link. The seeker guides the missile in the terminal stage. The data link receives navigation commands from a node in the network, guiding the weapon to the point when the seeker can pick up the guidance. A two-way data link can, in principle, return all sorts of data to the launcher, almost using the missile as a remote sensor. Very useful indeed. Actually, this protrusion could house the data link antenna looking backwards, like on the AMRAAM. But I'm willing to bet that it will also feature a home on jam mode, maybe with dedicated sensors to make home on jam really effective, therefore requiring some additional antennas, which could be integral antennas under these squares, under these panels near the radome. But the yellow band means something important. This missile has a live warhead. That suggests that what they were doing was separation tests, obviously, but possibly even launch tests. And to be fair, we don't know whether the aircraft returned with the missile or not. The two brown rings show where the solid propellant sits. And the propellant section looks slightly longer than that on the AIM-120, which means more fuel and more range. And this puts to rest the speculation that the missile is a two-stage weapon. There were some industry proposals, but there was no follow-up. The US has been researching a new propellant with up to 50% more energy density. If the AIM-260 uses it, together with the higher propellant fraction, that could explain the expected range increase if compared to the AIM-120D. This technology is called highly loaded grain. So, this is a solid propellant rocket. A solid propellant in a rocket motor looks like a cylinder, plastic cylinder, with a cavity in the middle. And the propellant is made by individual grains kept together by a binder. And the binder is needed because otherwise the grains would just fall out of the nozzle. The grain contains fuel and oxidizer, all mixed together like this. The fuel is typically an aluminum powder, even though in the United States they tend to use aluminum, while the oxidizer, well, the most common is ammonium perchlorate. Plus there are many others auxiliary components like combustion stabilizers, catalysts, opacifiers, and so on. The key thing to understand is that the propellant needs to be made ingrained, packed all in a cylinder with a cavity, because the combustion happens at the surface of the grain. If you have a big mass of propellant, this is the surface available for combustion. But if you break down the same mass in a number of grains, then the surface that can be used for combustion increases massively, like this. And this allows for the violent reaction that actually generates overheated gases that going through the nozzle generate thrust. Normally, the percentage of grain in the propellant mix is 70 to 80%, depending on the application. The highly loaded grain is a technology that allows to push the density up to 90%, reducing the binder percentage, thus achieving higher energy density. The principle has been known forever, but till recently, high-loaded grain propellants tended to be brittle, so not practical, and they lacked combustion stability, and in general were unreliable. However, recently, Raytheon and Anduril have announced a technological breakthrough that allows production rockets to feature this type of propellant. And it would be very strange if the AIM-260, a weapon that is so range-hungry, so energy-hungry, would not feature anything like this. The engine is almost certainly a dual-pulse engine. A dual-pulse engine, which should not be confused with the dual-thrust, is an engine like this. The propellant in the rocket motor is divided into sections separated by a barrier. The rocket ignites the first section at launch, which will burn down completely till it reaches the barrier. So the boost stage will accelerate the weapon to high speed and high altitude. There is no estimate of the peak velocity, but it will easily be in the range around Mach 5. Then the missile goes into an unpowered flight till when the controller, either inside the missile or outside, decides to ignite the second section. The gas will destroy the barrier and propel the missile to a second phase of powered flight. Having the second burn near the target ensures that the weapon has much more energy in the terminal phase, becoming much more difficult to evade. The so-called no-escape zone, the volume of space where the target cannot kinematically evade the missile, is much larger with dual-pulse engine if compared to a single thrust or a dual thrust. However, the dual thrust as such doesn't have a massive effect on range. Range depends from the energy available and how efficiently the missile can use it, so flight trajectories. Though it is very likely that the AIM-260 will fly the same kind of highly optimized trajectories flown by the latest variants of the AIM-120 to extract literally every meter of range and joule of energy. Yes, because a weapon like this was born for terminal engagement at long range. That's what the Air Force and the Navy said it was the main requisite for the weapon. But if this is the case, then another feature that we saw in the picture is really puzzling. So the AIM-260 has no mid-body control surfaces. It is understandable that reduces drag and increases range. Furthermore, very high-speed missiles produce enough lift from just the missile body. They don't need mid-body wings to fly. But this choice also reduces maneuverability. In fact, the mid-body surfaces can be mobile, increasing the missile maneuverability, or can produce additional lift when the missile slows down. And this extends the range in the terminal stage, at the very end of the missile flight envelope. Some observers speculate about thrust vectoring, but there's literally no evidence. And thrust vectoring only works while the motor is burning. At very long range, with the motor off, the missile will rely only on its tail fins, meaning it may be less maneuverable than Russian and Chinese missiles in the final seconds of flight, in the engagements at the very long range. It is possible that the Americans believe that these long ranges will be used only to engage lumbering aircraft like AWACS, tankers, and so on, so it doesn't really need to be maneuverable, but Chinese and Russian missiles might have an edge on the AIM-260 at very long range. To be honest, this is a bit off. I'm not sure to understand exactly what's happening, but this is what we see. Sorry, I actually realized that I forgot to say something. It was something that I actually wrote down, but while editing the script, I deleted the paragraph and I didn't add it anymore. So it looks to me that this weapon, the AIM-260, is a bit larger than the AIM-120. Not by much, but a bit longer, and the diameter of the body could be a bit fatter We're probably talking few centimeters in length and probably maybe 1 centimeter in diameter, which actually would explain why there have been some rumors of integration problems. I mean, it is surely being designed to fit inside the base of the F-22 and the F-35, but maybe the tolerances are too small. I am pretty sure that in the original specification, the form factor was expected to be the same as the AIM-120, but it is possible that to achieve the range that they wanted to achieve, they had to build something slightly bigger. I may be wrong, and the only way to prove me right is actually having more pictures. Back to the normal video. Here's where we are. China already fields a 3-tier missile family, PL-12, PL-15, and PL-17. And now the United States is moving forward its own triad, AIM-120, AIM-260, and AIM-174B. But one big difference, the AIM-260 is late. It is troubled and is still not ready. But now, at least, we have seen it. Now we are sure that it exists. And we'll keep following its development because this missile, once it finally works, may take some time, but at some point I believe it will work, well, then it will shape the next decades of air combat. Don't you think so? So, thank you very much for watching this video. It has been an honor and a pleasure having had your attention. A particular thank you goes to all those who are supporting the channel financially on Patreon or by being a member. By doing so, they have a picture of what is going on behind the scenes. However, if you can't support the channel financially, just please subscribe, leave a like, interact with the video, write a comment. It's the best way of telling the algorithm that you want to watch these videos, so you will be notified when a new one drops. And you're telling the algorithm that this was an interesting video, so it will be shown by other people who could be interested. So, this is it for today. Thank you very much for watching, and see you next time.